So the next that we'll be looking at in this series on inspection and testing is the medium voltage air circuit breaker. So in the air circuit breaker we have the arc quenching medium as air. Okay, the one we looked at previously is an air circuit breaker though, but a molded case circuit breaker. So what we'll be looking at, basically they are the same thing. We compare the nameplate information with the specifications that we have or drawings. Okay, so this is the nameplate information, this is the rated current. Okay, then we have the rated current, which is 1200 amps. Then the rated voltage, here we have 4760 volts of 4.76 kilovolts. So we want to check to see that it is as what is required on the circuitry. Okay, it is as what is required on the circuitry. So if you look at what we have here now, this bus is a 480 bus, while the input is 13.8 kilovolts, okay, which is what we have here. Okay, so the breaker that you'll be having here should be able to withstand this amperage and should be able to work comfortably in this voltage environment. Okay, so that is what we need to check out for. Then we need to look at the physical, that the circuit breaker is physically, we need to check that there are no signs of stress on the circuit breaker. Okay, so we need to check all the component parts to see that there are no signs of damage. Then the anchorage, we also need to check it to see that it is firm. If it is the one that we are racking in, we also want to check that the racking in and out is smooth. Okay, all the mechanisms, they are operating properly. Also to the grounding connection, we want to see also that they are firm. We want to verify that the unit is very clean, so that there are no debris or dust. If there are, we need to clean it. Okay, then if it is something that we can open it and check the arc chute that they are intact, and so we can check the arc chute that they are intact and they are working properly. So we can open it up and inspect to see that there are no molten metal deposited on them or dirt or debris deposited on them. If there are, we clean it up. Okay, we open the arc chute and then clean it up. Then the movable and the stationary contact, this is the stationary contact and this is the movable contact. Okay, we need to check their condition to see that they are clean and they are properly aligned. Okay, so that we have the most minimal resistance across that contact as much as possible. So we also want to close, if it is possible, the circuit breaker and check for one, that the contacts, they are not binding together. That is, when you expect them to open, they will separate. Even in that slow motion, they will separate, and that the friction between them is as minimal as much as possible. Okay, then the alignment too, we also want to check that it is properly aligned. We also want to verify that all of them are closing at the same time, not that one is closing first and the others are not closing. So all of them must close at the same time. Okay, because if you close such a breaker that they are not that the contacts are not closing at the same time to an inductive load like a motor, you can cause single phasing and thus damage the electric motor. So we need to circle the breaker as we said earlier. We switch it on, off. That is, we circle the breaker. That's to help us to verify that the operating mechanisms, they are operating properly. We charge on, then switch off. Okay, we charge again, on, then switch off. So if that happens, it means that it is operating properly. So if there is access to the bolted connection, we want to check that the bolts, they are firm, especially for breakers that have been connected already. Okay, or if we check the bolted connection that they are firm with the use of a torque wrench, calibrated torque wrench. Then we'll compare that value with what we have in our facility or what is recommended by the manufacturer. If there are none, then we can use this table, okay, this torque value table for electrical connections. So you see that there are different torque values for different grades of bolts and for different sizes of bolts. Okay, so we want to use the appropriate torque on the respective sizes of bolts. So we also want to check to see that the circuit breaker and the cell into which the circuit breaker will be racked in, they are properly fit, and that there are no hindrances on its way into the circuit, that is into the switch jar. Okay, so as we said earlier, the racking mechanism, we also want to verify its operation. We rack it in and to see that the travel is smooth, and then we rack it out to also see that the travel is smooth. If it has puffer, we check the operation. Then we also want to check that we have proper lubrications, okay, on all the sliding, moving parts or rotating parts, whichever. Use the recommended lubricant on all of these joints. Okay, so we want to lubricate them appropriately. All of these joints, all of this, the movable part is, that is the hinge joints on the movable part, and all the ray through which the circuit breaker is sliding into the cell. We have to lubricate all of them.